Graphing quadratic equations. So today we're going to finally finish off this unit by graphing our quadratic functions by answering these questions right here. So I want you to know that basically the quadratic equations, if they're functions and graph correctly, either will look like an upward parabola or downward parabola. To spell it out, Parabola, parabola. Okay, para. I hope you know what that means, like two pairs. Okay. All right. So given that, first question is which way does the graph face? So what they mean is this going to be an upward like this one or a downward like this one? Okay. So to determine that, you look at the value of the a. In this case, the a value is 2, which means a is greater than 0. Then we say it will be an upward parabola that will look like this. So it's upward because the arrows go upward. Okay. So we are going to use this as information to predict that, oh, that's how our graph should look like at the end when we are done with all these questions. Then question B says, what is the axis of symmetry? So like I said, it's a parabola. So axis of symmetry is a line that goes down this middle of the parabola, and it's a symmetric shape for left and right. So from here to here and from this point to here should be exactly same distance if it's a correct parabola. Okay, so we're going to find where that line is, where the middle line is. So it'll be x, we're going to use x is equal to negative b over 2a as a formula. So negative b, so negative 4 over 2 times 2. I'm using the a, b values from the actual equation. So it'll be negative 4 over 4, which is negative 1. So we're going to have an axis of symmetry of x is equal to negative 1. Okay, the line will form, the middle, the where it folds will be at negative 1. So then we're going to find where the vertex is. Vertex is a point where the line would turn. Like for example, right here, it would turn at this yellow point, and notice how it lands right on the axis of symmetry. So we're going to use the idea of x equal to negative 1 to find this point. So since we already know the x value for that vertex, that point, which is negative 1 in this case, we are going to simply plug it into the equation and to find the y value to complete the point. So it'll be 2 minus 4 plus 1. Sorry, this is 1. So it's negative 1. So we have a vertex at negative 1 and negative 1. Okay, so we found our first point. Then it says, what is a minimum or maximum? The reason why it's minimum or maximum is because if it's an upward like this arrow is indicating that it's gonna go upward forever. Then would you be able to find the maximum? No, because it's going on forever. But can we see our lowest point? Yes, it's at vertex. So given that, we are going to find our minimum for this specific one, and that minimum is going to be at y is equal to negative 1 because that's where the vertex is. I got that value from part C. Then question E is asking what is the y-intercept? Okay, so the y-intercept is going to be, we let x equal to 0 like we always do to find the y-intercept. So y is equal to 2, 0 squared plus 4 times 0 plus 1 equal to 1. So we have a y-intercept at 0, 1. So far we have found 1 point and 2 points. Okay. All right, so now we are going to answer the question F. What are the zeros? Zeros mean what are the x values when y is equal to 0? Okay, so do the opposite of part E, y equal to 0. So when we let y equal to 0, it turns out to be 0 is equal to 2x squared plus 4x plus 1. Notice how that's what we've been doing for this whole unit to find the x's when the equation is equal to 0. So you can use either the factoring method, quadratic formula method, or completing the square method, whichever that we cover this whole unit that makes sense for you. So after I've done that, I found that the x's are going to be either negative 1.7 or negative 0.3. In other words, my zeros, the points are going to be negative 1.70 or negative 0.30. Okay, so how many points have you collected? We've collected 4 points total. So notice how it's like, if you guys have played video games before where you collect the items, like as you go, you collect one at a time, and then at the end you get to the final goal. Same thing here, we were collecting 4 points as we go, and then we're now ready to graph it. So we found out in question B that our axis of symmetry is going to happen at x is equal to negative 1. So I'm going to draw that line first. By the way, it's an invisible line. It's just to indicate that that's where the midpoint or middle folding area is going to be. And then we found out the vertex is at negative 1, negative 1. Plot that point. And we know that the y-intercept is at 0, 1. We also found that the zeros that are negative 170 and negative 30. Alright, so what you have to recognize here is that these 2 points are exactly same distance away from the axis of symmetry. And remember, parabola is a symmetrical shape. So given that this point right here, our y-intercept, will also have its pair right here that's same distance away. Alright, so given that, we are ready to plot our parabola. We have 5 points. That's enough for us to estimate our parabola. That would look like this. That will be symmetrical by the x-axis, the axis of symmetry. And that is it. And we did predict that our graph will be upward, so that is also correct. Okay. All right, so given that, I would like you to try example 2 as well first by determining whether it's going to be up or downward. Find the axis of symmetry by using this formula right here. Then given that x value, find the y value to complete the vertex. Given the y value of the vertex, find whether it's minimum or maximum. What is a y-intercept? Let the x equal to 0. What are the zeros? Let the y equal to 0. And then graph all the points that you have collected. Alright? And again, if you have any questions, please email away or come join me on Google Meets.